A digital image is not an exact snapshot of reality. It's only a discrete approximation. After capturing the original digital imaging, we can post-process the image to find more information if need be. This allows us to display the information we've captured in many ways. So let's take a few moments to look at the process of image capture, image manipulation, and image display. Digital imaging techniques are set to capture anatomy and physiology. Ionizing radiation interacts with tissue density to create proportional intensities captured on the image receptor. The data is creating a histogram which is used to display the image. The display can be changed through data manipulation. Here we can see how a lateral knee was created using bone, soft tissue, and air. The computer creates the image almost like a paint by number, and the number of pixels you have determines the spatial resolution. Each picture element in the active matrix array can only have one color or one shade of gray. The computer uses an algorithm or histogram to display the image selected. The probability of interaction with matter depends on the initial energy of the photon, density and thickness and atomic number of the tissues, and number of photons available. Also, the anatomical information comes from the varied interactions across the anatomy. Naturally, the more distinct shades of gray we have, the closer the image is to reality. In digital, we have thousands of shades of gray to choose from. In film screen, 256. Here we'll use 256 shades of gray for an example. Notice we are only selecting the numbers 50 to 150 of the shades of gray to utilize in creating the image. We use these shades of gray to give us our brightness and contrast. Capture of the intensities is either direct or indirect. The key points of X-rays being absorbed by tissue is the loss of their energy is variable to the extent at which it passes through the body. The X-ray image receptor is exposed to correspondingly different intensities to capture. X-ray attenuation depends largely on the average atomic number of the tissue's thickness, and the density. They all have a role to play in creating the image. When these tissues are mapped, resolution and contrast depends a lot upon the number of shades of gray, or the bit depth, and the number of pixels per inch. To adjust the brightness and contrast of the H&D curve that is displayed on your control panel, you can either change the straight line portion or slope of the curve to be more vertical, which will change your contrast, or you can move the straight line portion either to the left or to the right, which will make it lighter or darker. That's an example of basic post-processing of an image. This is Mark Struthers. This is the first of our technical shorts, and we'll have more to come.